Welcome to Learn to Write Functional JavaScript. My name is Michael Rosada. I was fortunate enough to grow up in a house that always had a computer and to have a father who worked in computer security. Very likely the same as you, I was the person whom people brought their broken things to, and I always enjoyed that. When I was young, I played around writing basics, some early Flash, HTML, but it wasn't until I was older that I actually got into programming. Started with PHP, quickly moved to Python, JavaScript, Node, a bit of shell scripting, and Haskell. I've been a professional JavaScript developer now for 4 years. I started building web pages and widgets and then web apps. I've worked a couple large web apps still in internal use by franchises using JavaScript as well as Apache Cordova. I love the JavaScript ecosystem and the community. It was this community that first introduced me to functional programming a few years back. At that time, I assumed functional programming was another internet flavor of the week. I've never been so happy to be so wrong though, because functional programming has become a passion of mine. I'm the founder of the Mass Web Devs Meetup Group. We're a meetup group in Massachusetts. Currently, we're building a small web app for a nonprofit. When I find time, I write about development, mainly JavaScript, at onethingsimple.com. Late 2016, I began a YouTube channel that focuses on JavaScript, and in my spare time, I read. I absolutely crave to be learning new things, after which I enjoy playing guitar and solving chess tactics. This course is for those who wish to gain a deep understanding of functional programming. I've structured it so that those with little or no functional programming knowledge can learn important concepts in the right way and gain a strong foothold to truly understand what functional programming in JavaScript is and what it isn't. There are 4 sections to this course, each critical to understanding functional programming. They are cornerstones of the paradigm. The first section teaches one of the pillars of the functional programming paradigm, which is pure functions. We see what pure functions are, how to refactor impure functions, and how to solve problems by combining only pure functions, and also why doing so would be desirable, and why it creates a predictable environment and solution for our problems. The second section introduces higher order functions. Almost every function in a functional program is a higher order function. They're typically more flexible, reusable, and they can replace low-level constructs such as loops. We'll look at 3 very popular higher order functions: map, filter, and reduce. You'll see how they work, why and how to use them, and you'll even implement your own map, filter, and reduce functions to create utilities that are on par with functional libraries such as Lambda.js. We'll also look at how higher order functions can be used to render higher order UI elements to the DOM. This is a great way to share functionality between components without coupling their logic. In section 3, we'll cover partial application and currying. These concepts are extremely powerful. Learning them will make you a better programmer in general. You'll understand how to take advantage of currying because you'll be writing your own partial application and currying utility functions. Learning how to implement these utilities yourself, this will cement your understanding of them, give you the tools to turn standard functions into higher order functions anywhere in your program. You'll understand quickly why curried functions are such a huge part of functional programming, and in fact, purely functional languages usually have all native functions curried by default. In section 4, we'll look at immutable data structures, how to work with data structures using lenses from the functional library Lambda. Lenses are higher order functions that make viewing and setting properties on immutable and nested data a lot simpler. They will also come in handy a lot in future volumes as well, because lenses can be composed together. We'll be building a web app using Webpack and Babel. It'll use JSX for templating, just like React does, except we won't be using React. We'll be writing the underlying DOM implementation ourselves. This will allow us to write stateless DOM components for our app, which will make our templates more deterministic, just like our pure functions. And we'll also add the virtual DOM library so we don't have to sacrifice performance for the sake of our new stateless UI. In this course, you'll learn the fundamentals of functional programming, concepts that apply to all of functional programming, but which will also make you a better programmer in non-functional apps as well. What do we need to begin our journey? Node should be installed on your computer. Besides a few examples, we won't be using Node directly, but we'll need it to run Webpack and Babel. Version 6.9.2 was the version in which Node gained the majority of ES6 features. At the time of this recording, Node 7.8 is the current stable release. I recommend using Node Version Manager. It makes life a lot simpler to switch between versions. NPM is the package manager that comes with Node. I suggest using Yarn instead. It will ensure all your packages install exactly the same as mine are on this project. Both NPM and Yarn use the same repository for packages, so that's just a recommendation. Babel lets us run cutting-edge JavaScript in any browser. It's already set up in the course project for you. Webpack runs our code through Babel, builds our project. This is already set up for you. Webpack Dev Server makes viewing changes in the browser quicker. This is already set up for you as well. This is a URL for the GitHub repository that has the basic project environment set up and the starting files that are used throughout the videos. Simply clone the repo by following the on-screen instructions or the instructions at the GitHub repo site to get up and running.